Okay. Start. Okay, so if fx equals to that and gx equals to that, the first one is easy. So the first one, we think about the domain and the range for f and g. So domain of f is R, and range of f is R as well. Maybe it's not R. Range is some value to infinity because it's a quadratic and it's a smile face quadratic. I'll have a minimum value and all the way above. And think about the domain for G. The domain for G is R, and the range for G is R as well. So now let's think about this. I put the G function into the f function. Okay, I put the G function into the f function. So what we have is we put some x into G first. I will have the range of G coming out, and I'll put the range of G into the fx now, and to produce a value. So think about the range of G. The range of G is R. Okay, the range of G is R. And the domain of f is R as well. Okay, domain of f is R as well. So no matter what I put into the function f, it is alright. Okay, there's no restrictions for f. So we can say we can put anything in this function. Okay, there's no restrictions here. Because I have no restriction what I can put into G, and there's no restrictions that what I can put into F, so there's no restrictions for both functions. Basically, I can take R into my function for the first one. So that's why I said the first one is easy. So you want to find the rule for FGX. So you put G into F. So you put G into F. So Gx is x minus 1. Instead of x, you will write x minus 1 for every x in f. So you write x minus 1 squared plus 2x minus 1 plus 5. Okay? So you have all of that. Change to x minus 1. That's how composite function works. You put one function into another function. And you can simplify that by yourself. I'm not going to simplify here. Okay, think about the next one. If gx equals to x cubed plus 1 and fx equals to square root 2 minus x, then what is the largest possible range of gx such that fgx is defined? Okay, so understand the question first. I want to find fgx. Okay, fgx. I put g into f. So I'm asking, what is the largest possible range of g? That is my question. Okay, I'm not asking you anything else. I'm asking about what is the largest possible range of G I will have, the range of G. So what is the range of G important? We put G into F. Okay, we put some X into G, and we have the range of G. And the range of G will pop into Fx now. But now I have restrictions for Fx, the domain of F. Okay, what's the domain of f? It's a square root function. It's 2 minus x. My x needs to be smaller or equals to negative 2, not negative 2, smaller or equals to 2. Because 2 minus x needs to be greater than 0, and my x needs to be smaller or equals to negative 2. Smaller or equals to 2. So my domain of f is that. My range of g is to be inserted into the f of x. Therefore, my range of g needs to be satisfied between those range. So my range of G, so largest range of G equals to negative infinity to 2. Okay, negative infinity to 2. So what is the largest range? So it's the largest domain for F. Okay, you're looking for the largest range for G, you're actually looking for the largest domain for F. Okay, next one. Next one, we have f equals to that and g equals to this. We have hx equals to g of f of x. And then what is the equation and domain for h of x? Okay, now is the important question is, what is the domain for hx? Okay, let's think about what's the domain for h of x. I put f in G, right? I put f in G. So I put some x into f. So what I put into f, let's say, what is f of x? F of x is square root 2 plus x. I put in that, and I have some range of f out, and I put this range of f into the function of g. So the function of g will be x squared plus 5. But the domain for this is negative 5 to infinity. I have a restriction on the domain of that, which is negative 5 to infinity. Okay, now let's have a look at that. What I can put at the beginning, okay, what I can put at the beginning, I will use a green color to write. What I can put at the beginning is negative 2 to infinity. That's the largest value I can put because that's a square root function. I have restrictions there. The domain given to me for f is negative 2 to infinity. And let's think about what's the range. Okay, what's the range? So what this graph looks like? This graph looks like this. Right? That's the square root x looks like. Okay, I start from the point, end point is negative 2, 0. Okay, let's write negative 2, 0 and moving like that way. Both positive, going up. Okay, so we have this graph. And what is our range? What is our range? Our range is 0 to infinity. Our range is 0 to infinity. Okay. Can 0 to infinity be substituted in negative 5 to infinity? Is that fit? Is that like alright to put into gx? The gx can take those values? Yes, you can take those values because actually the domain for gx is larger actually. It's negative 5 to infinity. If you can think about that, that's negative 5 to infinity. I can take those. But what the value I actually have out is 0 to infinity. It's actually a subset of the domain of G. Okay, it's a subset of domain of G, which is alright. So I can just take this value. So that is alright, which means my domain is alright. So what is the domain for hx? Which is negative 2 to infinity. And what is the rule? So g of fx. Put fx into g. So fx is this. Put into g. We have x plus 7. X plus 7. Okay, square root of that square is 2 plus x. 2 plus x plus 5 is x plus 7. Okay, so if you want me to write into function notation, write that into function notation, so I will do h, what is the name? Is h, negative 2 to infinity, mapping to r, hx equals to x plus 7. Okay, that's my function notation. Okay, the question on the first page is kind of easy and then it increases like the difficulty levels later. Okay, so next one. Consider about the function fx and gx. Okay, write down the domain and the rule for g f of x. Okay. So for g f of x, so what is fx? Okay, I have the domain for gx is 0 to infinity. Okay, so at the start, I can put the domain which is negative a third to infinity, which is restrict for me already. Okay, and put -3 to infinity. What's the range for a log function? What's the range for a normal log function if there's no restrictions? What's the range for log? Yeah? Okay, what logs looks like? Think about what's the graph. So it's from bottom to top is R. Okay, the range is actually R, but domain is positive. Domain is positive. It's totally opposite way as exponential. Exponential domain is R, but range is like below or above the asymptotes. Okay, so, but have a think about this graph. Is that a whole graph for log? Where is the asymptotes for this log? Where's the asymptotes for this log? Okay, is a horizontal asymptotes or vertical asymptotes for log? Horizontal asymptotes or vertical asymptotes for log? You haven't learned log before? I think you should learn log last year. Should be a vertical one. Okay, should be a vertical one. So what is the vertical one? The vertical asymptotes will be 3x plus 2 equals to 0. When that value equals to 0, that will give you the asymptotes. Okay, so x will equals to -2 on 3. That is where your asymptotes start. Okay, that is where your asymptotes. So if you can draw this log function out, okay, let's say that's -1 and -2 over 3. I have this asymptotes here. Okay, check when x equals to -1/3. My domain start from -1/3. Okay, the domain start from -1/3. It's not start from -2/3. So I need to find where's the endpoints. Where's the endpoints? So f -1/3 will equals to log e -1/3 times 3 plus 2, which give me log e1. What is log e1? What is log e1? Be confident. 0? Okay, that's 0. So when x equals to -1/3, y value is 0. Okay, that is my y value. And the graph should be, actually it should look like this. Okay, that's a log function. That's a log function. But the start point is -1/3. I only have this part of the graph. Okay, I don't have here. You shouldn't draw the dashed lines, but I want to show you what the full graph looks like. So you start from -1/3 to infinity. So what's the range for f? See this graph? What's the range for f? 0 to infinity. Okay, or r plus union 0. So it's 0 to infinity. Is that all right to put into the gx now? Is that domain a subset? Yes, it's a subset, right? 0 to infinity, I just fit the 0 to infinity. So there's no problem with this, and there's no problem with this. So I can take that domain. I can take that domain at the beginning. And I want to do, so what is g f of x? Put fx into gx, so instead of x, I will write log e 3x plus 2 and subtract the 1. So if I can write that into function notation, is h -1/3 to infinity mapping to r, comma, hx equals to log e 3x plus 2 minus 1. Okay. Do we have any question about this? Okay, for all of those 4 questions, there's no problem with the range to substitute into the next function. So that's the lucky case. Okay, there are the range for the top function is all a subset of the domain of the next function, that's the lucky case, because I don't need to go back to change the range to change the domain. Okay, save some time. But let's look at the next question. Let's look at the next question. Please stop talking. Let's have a look at example 5. Example 5 asks something else. Okay, example 5 asks about what is the range of the function. Okay, what is the range of that function? It's not asking domain anymore. It's asking range. Okay, so how we can work out range? We need a last step. Okay, we need another step to work out. Okay, 0 to infinity put into -1 minus x minus 1. What is the range? We need another step to find the range. Okay, we need an extra step. So let's have a look at example 5. We put things into fx. Fx is x squared plus 3. And I have some value out. I put this value into log ex. Okay, what I can put in at the start? What I can put at the start? All the real numbers is possible because it says we have the maximum domain. So I can put all the real numbers in. Okay, what is the range for this equation? What is the range? This is a quadratic. So what is the possible range for this one? Something to infinity. 3. 3 to infinity. The graph looks like this, okay? 3 to infinity. Okay, so now you want to put 3 to infinity into log ex. Okay, do you understand that? You put 3 to infinity into log ex. What is the range you will have? Okay, what does log ex look like? If you're trying to sketch log ex, you will have x equals to 0 as the asymptotes, because x equals to 0 is the asymptotes. And we have this one. We have 1, 0 here. Okay, when x equals to 3, g3 will equals to log e3. Right? You put 3 into the function gx, it's log e3. So I have the point here. Okay, 3 log e3. And then all the way to infinity, so it's all the equations here. Okay, so it's basically from this green point and all the points above here. So what's the range? Log e3 to infinity. Okay, start from there to infinity. So the range of g of f is log e3 to infinity. Okay, so it's log e3 to infinity. Okay, I will show one last example for example 6 and ask you to do the rest by yourself. Example 6 can be quite complex, so please listen carefully and do not talk to each other, because you really need to listen. This is the time when the range is not fit the domain for the next one. Okay, so this is when it's not fit. I hope it's not fit. Okay, I think this is the not fit one. Okay, so first of all, what is f of x? What is the function fx? What type of graph is that? What equation? Linear, quadratic, cubic, polynomials, hyperbola, truncus, circles, which one? Which one? Okay, all this type, which one? What's the graph looks like? If give you this equation, truncus is quite similar to truncus. Well, what's the one really similar to truncus? Hyperbola? Okay, hyperbola is that one. Remember, if you have linear over linear, if you have linear over linear, that will be a hyperbola. Okay, x is a linear, x plus 6 is a linear. You have equation linear over linear, that must be a hyperbola. Okay, you can simplify that to make it to a hyperbola. So you have fx, not use red color, fx equals to x over x plus 6. Okay, so what we're trying to do is make the top look similar to the bottom. So the bottom is x plus 6. The bottom is x plus 6. So I will write x plus 6 on the top as well. But I only have one x, so I can't have the 6. So what I will do, like similar to completing square, I will subtract the 6 again. Okay, I'll plus the 6 and subtract the 6. It's still that fraction, but like I'm just trying to do something to that. And what I will do is x plus 6 over x plus 6 minus 6 over x plus 6. And that will give me minus 6 over x plus 6 plus 1. Okay, plus 1. As that looks familiar now, it's a truncus. Where is the two asymptotes? X equals to negative 6, y equals to 1. Okay, that's your truncus. And which two quadrant will in the first or the third or second or fourth? Okay, no, it's here or here. Okay, it's the same direction, okay? Okay, so let's have a think about this graph. Let's think about this graph. Okay, x equals to negative 6. And y equals to 1. Alright, so in this way, so I will have this graph here and here. Okay, so that's my f function. So what is my g function looks like? What is the g function looks like? For gx, where's the asymptotes? X equals to negative 2. Okay, not 2, negative 2. And y equals to 0. Okay, x equals to negative 2 is here. And one thing I want to emphasize is when you have asymptotes on the axis, y equals to 0 is on the axis, you're not supposed there's an asymptotes. You need to draw them out. Okay, you need to draw that out on your paper with some color pen and dash lines. Okay, you need to show the dash line on the axis. I see so many students just ignore that. Okay, there's some line, I suppose that's a asymptotes, and I don't need to draw it. Please draw it on the axis as well. And we have 18 is positive. If 18 is positive, I will get this part of the graph and this part of the graph. Okay, now let's do the work. First, okay, this is my gx function and this is my fx function. And think about this notation is to put g into f or to put f into g. Put g into f, right? G into f. So if you have g start with g, so what's the domain for g? What's the domain for g? Sorry, again? R except -2. So I will have r except -2 to put into this function. What's this function? Is the, I don't really mind, is the gx function. And what's the range coming out? What's the range for g? R except 0. Okay, and I want to put that into my fx. Okay, in my f of x, what's the domain for my fx? Right here. What's the domain for my fx? Okay, domain of f is r except -6. Okay, can r except 0 fit into r except -6? Yes or no? No. Which value is not? Which value is not good? Which value is the actual value? 0 or -6? 0 or -6. We have r except 0 and r except -6. Okay, think about, we have r except 0. Okay, we have an open circle here. This is what we have now. And what we need is r except -6. Okay, I can take all the values but not -6. Okay, I can take all the values but not -6. But what I want to give this function is everything except the 0. I have an extra -6 here. Okay, I shouldn't have this -6. In this part, I should take this -6 out from the range of gx. Okay, so what I need to change here is there needs to be a -6 and comma 0. Okay, I can't have 0 and I cannot have -6 to allow me to put all the things into the other function. So, okay, originally I can't take -0. I can't take 0, and now I cannot take -6. Let's think about, that's the range. My range cannot be -6. So what is the domain will give you -6? Let's go back to the gx function to see which value will give me -6. Okay, let's draw a -6 line here. Okay, that is the range to be -6. Okay, that's the range to be -6. I cannot have that point. Okay, I cannot have that point. I need to find out the x value for that point. So that's the gx function. So I will write my gx function to equals to -6. I'll see which value will give me -6. So that's x plus 2 equals to 18 over -6. X plus 2 will equals to -3. X will equals to -5. X will equals to -5. So my x cannot be -5. Because x equals to -5, that will give me the range to be -6. Okay, I don't want -6, so my domain don't want -5 as well. Okay, have a think about this question. Okay, have a think about this question. How it worked. Okay, how it worked. Okay, think about it. I'll give you 1 minute to think about what we have done. Okay, that's quite a lot of work. We need to consider both graphs, both equations, and we need to have, okay, first of all, x cannot take -2. That's what we have at the beginning. Okay, that won't change. Even though I go to change the domain, I still cannot take -2 because that's the restriction from my gx function. I cannot take -2. I will have a range with r except 0. But I go to check the domain for the other function. I cannot have -6 as well. So except the 0, I also cannot take -6. So I will go back to see which value gives me -6, which is the -5 gives me the -6. So I will exclude the x value of -5 out as well. So the domain for this composite function will be this. Okay, will be this.